So we're going to do a new thing. I'm recording it, kids are gone. But you learned to review your Pythagorean triplets. And I told you, as you go higher in math, you see those a lot. You see these even more. These are the two special right triangles. Special because they are used a lot, but also they come from the regular shape, equilateral triangle and square. But in physics, all over physics, to teach beginning physics, and I mean beginning at a college level, they use the special right triangles all the time. Probably to simplify the math in problems when they're teaching concepts. You know, not necessarily because it's always a practical application. And then in calculus and in pre-calculus and in algebra 2 next year, trig, you're going to see these all the time. So learn them by memory, but also know how to get them. And I promise you it will save you time, because every year you're going to find kids that didn't do that, and they're going to be behind all the time. Learn by memory. So in order for you to understand what I'm talking about, I need you to look at the shapes here. So I have an equilateral triangle here, and you would only know that if I marked it, which I don't have it marked, but if I write 60 here and 30 there, it's equilateral, okay? And so if you have an equilateral triangle from the last chapter, remember, if you have one side of the triangle, you should be able to figure out the area, because the altitude of an equilateral triangle is also the median and the angle bisector and the perpendicular bisector. So this segment intersects at a right angle, and then I heard Michael say cuts the base in half, so this is one unit, right? So you can find h with the Pythagorean theorem, because h squared plus 1 squared has to be equal to 2 squared. And so if I write that out the long way, yes, h squared is equal to 3, so h is the square root of 3. Okay? So this triangle, if I just take this triangle, you know, well, I didn't actually make the same size, but if I put, like, if I took the triangle out of the picture, you know, I would have a 30, 60, 90. This would be, we call it a 30, 60, 90 triangle, meaning that if I take half of an equilateral triangle, those are always going to be the angles. And if this is 2 and this is 1, this is always going to be the square root of 3. Always. Because the Pythagorean theorem is always going to give you the same answer when you have the same numbers. Okay? Right. Yeah, let's close the door there. Okay, so I'm just going to use the picture on the right. We're going to talk about how to just use this triangle over and over and over, and the property of similar triangles, which you learned in 8th grade math, to find missing sides, so you don't have to do the Pythagorean theorem every time you see a 30, 60, 90 triangle. And then we're going to come back to the square. Okay? So, you know how, I should throw in, we just did Pythagorean triplets, and one of the triplets that's easy to remember is a 3, 4, 5. And then if I took a triangle that was in the same proportion, like this one, and I blew it up, you know, So if I doubled it, that looks like it's about double, right? You guys just learned that if this were a right angle and this was 6 and this was 8, that would have to be 10, right? Those are similar triangles because their sides are proportional. 3 is to 6 as 4 is to 8, right? And when we cross multiply, we get the same number. That's one way to look at it. And then you also know that 4 is to 8 as 5 is to 10. And when you cross multiply, you get the same number. Or even easier, in this case, all the numbers, ratios reduced to 1 to 2. So if you know you have similar triangles, you can use that property to figure out missing values of 30, 60, 90s. So here's a 30, 60, 90, and you only have one value. So your goal is to be able to go home, and anytime you see a 30, 60, 90 triangle, find all the other sides. Because when you were in 8th grade, you learned that if all the angles of a triangle were congruent, so like this triangle, if I clone it and I shrink it, I've just kept the angles the same, so the sides have to be proportional. That makes them similar. So anytime I have a 30, 60, 90, so the sides would be in the same ratio as every other 30, 60, 90. Okay, so that's the idea. So no matter what these sides are, I know that they're all going to be related to the one that you just figured out over here on the left. Okay, so it takes a little bit of time to figure out what I'm talking about, but I'm going to take this triangle and you're going to commit it to memory, which is so fun for you guys because you all love to memorize. And you're going to use it over and over and over. And so if you think about it, opposite 60 degrees is the square root of 3, because that's like 1.7. So that's the middle length, right? The smallest value is 1, that's opposite 30. So the smallest value of 1 is opposite the smallest angle. The biggest value, 2, is opposite 90 degrees. And then this middle value, root 3, is opposite 60 degrees. So if I look at that and I memorize it, at first it seems like a lot of work, but I know now that I can take this and I can rotate it any way I want. So if I imagine it in the same position as the triangle I'm trying to solve, I could say, well, the triangle that I have memorized has a 2 here. And then I know it came from an equilateral triangle, so the short side had to be 1. And I did the Pythagorean theorem, and I know this is the square root of 3. Does that make sense?
You can just create a ratio.
Then you could just create a ratio. Whoa, look at that. So then you could just create a ratio. So I could take this triangle that I have memorized over and over and over and just keep making a ratio. So I know that the small side to maybe the, well, actually you probably want to do it visually. So like you could compare the 3 to the 1 and yeah, the x to the 2, right? And the y to the 3. So the color tells those are the relative, they're in the same relative position. So I could say 3 is to 1 as x is to 2 and solve that ratio. So x has to be 6. You get that? So that's the easy part. There are even, and we'll do shorter cuts in a minute. And then I could say 3 is to 1 as y is to square root of 3. That's just 3 times square root of 3. So 3 root 3 equals y. Okay? No. Yes. There's shortcuts. We'll get
Oh,
there.
that's what we had last year, said, like, it's just time to do,
Right, you might have done this last year. So we're going to stick with ratio and proportion for a few more minutes because it's probably your best fallback. It's easy if you forget the triangle. Like I've hidden the triangle you're supposed to memorize. But if you remember that triangle comes from an equilateral, the long hypotenuse is 2, the short side is 1, and you could always do a quick Pythagorean theorem to get the root 3 if you forget the triangle. As long as it's a 30, 60, 90. So you don't have to have the picture. But it's nice if you have it in your brain, because now I could say the square root of 3 compares to 2 as, what if I want to find W? W compares to 1. So, well, the W is over 1, right?
yeah, so you get root 3 and then you get 2W and
Yeah, so W is just root 3 divided by 2. You guys see where he's doing that? You don't need to really cross multiply and divide if the denominator is 1.
Yeah.
So W is root 3 over 2. And then Z, we have to find. So Z compares to, yeah, root 3. So as square root of 3 compares to,
It's confusing which one is
3. So I'm comparing the square root of 3, which is the hypotenuse, to the hypotenuse, 2. So now I have to cross multiply. So root 3 times root 3 is,
root 9, 3,
which is 3, right?
over 2.
Over 2. So you multiply what's on the diagonal, divide by what's left over, and you get Z. So 3 halves. Do you get that? You need to practice it a little bit. Want to try one? Let's try this one. And let's make this, we'll start easy. Make this 5. And find X and Y. And we'll talk about a shortcut in a minute, but just practice that. If you have it in your head, let me have your answer. What do you have, Tyler? Okay, and so usually I'm going to say, you don't see that. You're going to see it like this.
Yeah. That's what I have.
It's more common that you don't see decimals mixed with the radical sign. That's all. It's not wrong. So if you can't, so we're going to talk about shortcuts in a minute, but if you can't see where this comes from, remember you're always comparing to that base triangle, which was started with a 2, this was 60, 1 square root of 3. So if you wanted X, you'd say X compares to 1 as 5 compares to 2. They're just similar triangles, short leg to short leg, hypotenuse to hypotenuse. So in this triangle, X and 1 are in the same relative position. They're both the legs, the short leg. And the hypotenuse are both in, those are the numbers for the hypotenuse. So we know then, since X is over 1, X is just 5 halves, which is also 2.5. You could leave it as 5 halves. Are we okay on that part? So you don't have to write anything down for that, because the relationship between the short leg and the hypotenuse is a 1 to 2 ratio, or from the hypotenuse to the short leg, you're always dividing by 2. Right? You're just cutting in half. You can see that? Okay. So to get Y, you would just move this up a little bit. Put that over with the X. To get Y, you would say y compares to the square root of 3 as
Yeah, I see, okay.
what? What goes over here? 5 compares to 2. And you guys, doing similar triangles is important because you did do it in 8th grade. And we probably aren't going to practice any other similar triangles before you take that park test, and I guarantee you'll have similar triangles on there. So it's good to be able to do both, not just memorize, but set the relationship up.
All of these grades taking geometry?
Nope, just
Yeah,
you
I have
guys.
a question.
Okay, just let's finish this. So we're solving for y, right? So we're going to multiply by these two and divide by what's left over. So 5 square roots of 3, fraction bars mean divide, divided by 2. And that's what Tyler got. Okay? So, I want to clone the page and clear it, and then talk about what he's doing in his head. So what's your shortcut? What are the patterns?
X is either half the hypotenuse or the hypotenuse is double.
Okay, so whatever this is, if this is x, this is 2x.
And the hypotenuse is,
Well, the last leg is X equals.
So see,
And this is x root 3, right?
as soon as you find X, you find everything.
Frankly speaking, for me, I'm slower doing it this way. I'm quicker just setting up a ratio and proportion, but I can do it both ways. So if I had numbers to work with and I had a 30, 60, 90, because that's just me. You guys are really quick, you know. So suppose, here's what throws people. What if I put the square root of 3 here? Can I do that?
yeah, you would just,
Yeah.
you just work it out.
I could see.
This is square root of
9
3
times square root of 9.
Oh, so it's
over
times
2.
Yeah.
It's just cut in half.
Oh, yes.
How do you get from here to here? What operation is going on? What are we multiplying by? Right, we're just multiplying this by root 3.
So it's just,
So then to get here, it's root 3 over 2 times root 3, which is really just, what? What is that? 3 halves, right? Okay, so generally, that doesn't work for everybody, that method. It might work for a lot of you, but if this method, getting those doesn't work for you, do the ratio and proportion. Set up similar triangles. Which is the shortcut. And what if I put the square root of 3 somewhere else? So let's go a little farther down. What if I said this is now square root of 3, and this is x and that's y. New problem.
Must be 2 roots, 3 roots, and
Got it.
yeah.
This is
3, yeah.
2 root 3,
And the other one's 3.
and this is 3. And if you can't do that, or it's bugging you to do that, don't do that, right? Remember that you have the ability to just memorize a basic triangle. 2, 1, square root of 3. If this is 60. And if that works better for you, then solve, remember we didn't have the answers yet, solve the ratio and proportion. You could say root 3 compares to 1 as y compares to 2.
Good luck.
And so y is 2 square roots of 3. So you don't have to do it in your head. It's great to do both. And you could also say root 3 compares to 1 as x compares to what?
2. No.
As x compares
Yeah, so
to
root 3.
root 3, right? So cross multiply, and you get
X equals 3.
x equals 3, which is what we just got doing the shortcuts. Okay? Raise your hand if you don't have a system for finding the sides. Everybody can do it one way or the other? Okay. So then let's go all the way back to the beginning. And the other special right triangle is a 45, 45, 90. It's easier. It comes from a square. So if this is 1, these are both 1. By Pythagorean theorem, what's D? Really?
It's square root of 2.
Yes, it's the square root of 2, right? But this is so much easier. Oh, look I have my 1 in the wrong place. Whoops. For the beginning problem. So that's the triangle you want to memorize. Right? Or know how to recreate, right? You can either know how to build a regular quadrilateral, build a square, and find this diagonal, or memorize it. Okay, so if I want to use it, then I'm going to do the same idea, but it's just so much easier here. Let me put, hi. So let's add a page in there. You were supposed to go earlier?
Yeah.
Okay, so if I have any, this is an isosceles right triangle, no matter what the size. If I have that triangle on the left memorized, I can figure out the missing values. This could be the square root of 3. As long as I know that this is isosceles right, or a 45, 45, 90, I should be able to find x and y, and x and y are the same. I'm just going to say that the square root of 3 would have to compare to the triangle I have memorized.
So square root of 2.
Square root of 2.
Oh.
As x compares to 1.
So it's going to be root 3 over.
Yes, and you guys probably learned to do something called rationalizing last year. Whoops, where you multiply by root 2 over root 2 to get rid of that square root. Remember that? Square root of 6 over 2 is your final answer.
Would that be what you want us to do?
I think that you don't need to worry about that tonight.
But like
By the test, yes.
Test that.
You get that?
Yep.
So if it wasn't so messy, I just want you to see that even if it's messy, you could do it. If you had, 4 here. If this is isosceles right, and if this is x, they're the same. 4 compares to root 2, as x compares to 1. Practice rationalizing. You would multiply by root 2 over root 2.
So now you have 4 root 2 over 2.
Which seems worse.
2 root 2.
Over 2.
What's the shortcut? What's really happening? How did we get from here to there? How did you get from root 2 to 1 with multiplication or division?
You
Well, think about how you did it here. What did you do up here? You divided to get to the smaller number, right?
so divided by.
You're divided by the square root 2. Look at what my answer is. If I have the hypotenuse, then the leg is just divided by the square root of 2. Or, if you hate that, never do it. You know that x squared plus x squared, it's a square, is always equal to, in this case, Pythagorean theorem is so short, it might be quicker for you. 2x squared is equal to 16. X squared equals 8, right? So x has to be the square root of 8, which is 2 root 2. You have lots of choices there.
I think there's something.
So practice them tonight